preparing for this session, we sent our panellists, who, as you may have already guessed, Professor Jerke Lessing, Professor Jennifer Whyte, Professor of Practice Daryl Patterson, a brief provocation. I'd like to read this provocation to you, and then I'll introduce our respondents who've been explicitly instructed not to share notes with one another, and who'll give you all roughly a 10-minute response to this provocation. And obviously after that we'll have a panel discussion and hopefully a couple of questions from you if you don't think it was provocative enough. So here goes. At its core, Building 4.0 CRC proposes the marriage of two main currents in building innovation. The first is a continuation and deepening of the processes of industrialization in the building industry, effectively the transformation of building away from a construction logic towards a manufacturing logic. The second seeks to harness the suite of digital technologies and processes that are variously known under the banner of Industry 4.0. Please come on in. Just getting fired up. So after 2 years of operation, it's timely for us to go back and reconsider the relationship between these two currents. Are they as valid as they were when we first started? Will they be valid 2 years from now? And what's the right relationship between the two? As I wrote in an article in 2021, the shape of building innovation is changing. 20 years ago, it's almost guaranteed that a building innovation conference like ours would have featured industrialized building very, very high on its agenda. And I think it's safe to say that going down the path of industrialization was generally held as one of the most innovative things a construction company could have done at that time, learning from the auto industry, for example. So through industrialization and moving large amounts of production off-site and introducing manufacturing principles, it was felt that the industry could improve on cost, time, quality, and a range of other benefits. In this, and over the same period, digitalization was often seen as a supporting objective that could help achieve these aims. So let's fast forward to the current day, and we see a different scene unfolding. If we consider the global prop tech industry that we heard a little bit about just before in the previous panel, almost all businesses are focused on the intersection of the digital and the physical. Most prop tech companies would refer to themselves as technology or digital businesses. At the Industrialized Construction Forum held at Stanford University in February of 2022, which was organised, by the way, co-organised by Jerke, it showcased 4 new businesses developing an ecosystem approach. These businesses were all powered by sophisticated digital platforms and supported by building systems of varying degrees of industrialization. It would appear that many companies are jumping straight to digital transformation, and in doing so, largely leaving conventional building practices as is, or at least not altering them as radically as we first thought necessary. Clearly, the hope here is that sophisticated platforms and processes might be able to choreograph building design and production more effectively and efficiently than traditional methods, and even automate them. Take on board, for example, comments made by Brian Chesky, CEO of Airbnb, in a recent interview. In describing the company's strategy, he repeatedly points out, "We don't pour concrete." And he does this to delineate the border between the physical and the digital, where Airbnb clearly sees itself as a business sitting on the side of the digital. But he does this as if this was some kind of badge of honor, or as though he was sending a calming message, perhaps, to Airbnb's investors that, don't worry, we're not going to get into that messy part of the business called building. So while this trend to focus on the digital over the physical can partly be explained by the way businesses seeking investment are valued, for example, construction and manufacturing is typically achieve a lower valuation, whereas digital and technology companies have higher valuations. But I think there's more to it than this. This session asks if there are other factors at play, or if this trend towards the digital is wider than building alone. Maybe it's intrinsic to contemporary ideas around innovation itself. As the investor Mark Andreessen famously said in 2011, software is eating the world. And we'll hear another take on that in a little while. So I think it's an interesting time to revisit the intersection of industrialization and digitalization to better understand and articulate their interaction. Is industrialization the first step to be supported by digital tools and processes? Can we leapfrog industrialization with digital tools and processes and leave the current modes of production intact? Or is there a dynamic relationship between the two, a dualism, if you like, that requires both parts to succeed in order for the whole to succeed? That ends the statement that I sent to our speakers. So now I'd like to introduce properly our first speaker, who, as we know, is up in Malmö. Jerker Lessing is adjunct professor at Stanford University and head of research and development at Boklok. In 2013, Jerker started teaching an industrialized construction course at Stanford, and in 2014 co-founded the Industrialized Construction Forum, also at Stanford University, as we just heard. Jerker did his PhD at Lund University in Sweden and focused on the strategic aspects of industrialized construction. I first came across Jerker's research through one of my doctoral students, Duncan Maxwell. Where are you, Duncan? And that demonstrated to me that Jerker had established what I consider to be the best framework for describing and analysing industrialised construction that there is. Jerker's framework, I think it's safe to say, has had a huge impact both on academic research and also on industry development. Since 2015, Jerker has had the position of Head of Research and Development at Boklok. As some of you would know, that's a joint venture between construction giant Skanska and IKEA that needs no introduction. Boklok has become one of Sweden's leading housing companies within the industrialised construction paradigm, and I'm also very happy to say that Jerker also sits as a member of Building 4.0 CRC's Industry Advisory Committee. And with that, I'd like to hand over to Jerker, and we can cue up Jerker's presentation. Thank you.
Thanks a lot, Matthew, and thanks a lot for both the introduction and for having me in this panel. I'm really sorry that I couldn't travel to Australia this time. I hope to do it soon, but this time we'll have to do with the digital solution, and that works well, of course, too. And thanks also for the provocation. I think that's super relevant, and I think it's super interesting. I will give you my view on this, as at least as a spark to the discussion that we will have. And my first slide was actually a little summary of who I am, but I think actually, Matthew, you did a great job in that. So I think I'll skip that. Maybe I could add that Boklok, as you mentioned, it's a collaboration between Skanska and IKEA. We have been around since 1996, so 25 years. We have built around 14,000 homes, and we are very established in Sweden, but we are also present in Norway, Finland, and since 2 years back also in the UK, where we see huge potential. So that's maybe a little add-on to this. So the discussion today, is it industrialization or is it digitalization that will be the guiding star or the most important spark for accelerated change in construction? So what I was preparing for this is actually to go back to my view of what industrialized construction is, because I think, at least to me, maybe this is more mainly for me to have something to connect the discussion around. But going back to a description of what industrialized construction is about, I think might shed some light on this question. So what is industrialized construction then? Well, the fast answer is that it's all this. Okay, so what is all this? Well, these are a number of different aspects. that I think are required to make up the concept of industrialized construction. And as you can see, there are many different aspects. There are even actually some more that are hard to get on a picture. But I think obviously prefabrication, automation, and production methods are there. Maybe some of the things that you come to think of when you think of industrialization. But you can also see that there is the use of digital tools and systems. It's there already from the beginning. But we also have standardized technology, standardized processes, we have planning, we have long-term relations, we have logistics, and not least, we have customer and market focus. So to really make sure that we are producing, buildings, homes, offices, hospitals, or whatever we are building that are in line with our customers' needs and what the market requires from us, with all the prerequisites that are put on this. Then you could argue saying that, okay, yes, but we have heard this before, we have heard it for many years. Standardization is nothing new, and planning has been carried out since the beginning, and so on and so on. And all that is, of course, true. But this is the thing. The thing is that all these aspects need to be integrated. They need to be put together. You need to get some focus on a certain type of products or a specific part of the market or some kind of specialization, and then you have to integrate these different aspects into a product and production system, working together over time beyond the singular project scope of one project. We need to have much longer horizon, and then getting this to work as a system over time, and then getting the benefits out of it as we want to. That's what I mean. That's when it gets industrialized. Otherwise, it's just working as we have always done. So first point here is that industrialization is not only prefabrication and manufacturing. All these parts that are, you can see them also here in the blue wheel, all these parts must be considered, I say, and they need to be integrated. You see digitalization is there, just want to stress that. But the thing is that the starting points of a journey, of an industrialization journey, can differ. You could have the start in digitalization. We see more companies doing that now than 20 years ago. But you could also have the start in really, really thorough planning. You could also have the start in prefabrication, or you could have it actually in technical systems or building systems or product platforms that we also can call it. So I think this could be a summary of saying that there are very different recipes how to address these challenges, but I argue that the ingredients, meaning these 8 or actually 9 themes or subtopics, they are the same and they need to be there to some extent. And the radar chart here says that, and the curve, that's just an example of one company, what the different emphasis on the different topics that they have chosen. Another company could have a completely different pattern, having a spike in other topics, slightly weaker in others, and so on, to fit with their business scope, their business idea, their part of role on the market, and so on. And this, I think, is super important to remember, that there's not one recipe how to address industrialization, or I mean, the overarching theme is, of course, to achieve change. And there's not one recipe, there are numerous recipes. Ingredients are the same, but you can have different starting points. But I think also important to think of is if we want radical change, then new business models are needed compared to what we are used to seeing in construction. And one part of a new business model, or sort of radical change in and applying industrialization, is to use platforms. You mentioned it, Mathew. I think this is super powerful. It's about structuring our technical solutions and our processes in platforms. We see it in many other industries, and there is a huge opportunity for us in construction to adopt that and create it to fit with our needs. Then it can be a backbone in the company. It can really clarify our product limitations, what we can do, and keep us laser focused on what we should do. And it's a systematic way to manage our products and processes and projects. I mean, we have to have that balance to look beyond the singular project, work with platforms and the way we are working. But of course, that has to really reinforce the way how we execute our projects. Because that's what we do at the end of the day. Okay, so platforms, is that one way to do it? No, same there. At least 4 main platform strategies are there, ranging from a fairly low level of pre-definition of the product, the building that we're building, ranging to a very standardized level, where it's basically standardized products that we build, and we can almost select the variant. And there's a super interesting range there, very strategic choice to make. What level should we be at in order to achieve and fulfill our customers' needs and wishes? And the thing here, if we want to work with platforms, well, then we really need to work with powerful digital solutions if we want to succeed with this. So this could be one way also where it really meets. Industrialized processes meet digital solutions, and also digital processes, of course, and opportunities in that. We can come back to what this can mean during the discussion. So to sum up, I think it's pretty obvious our industry needs to improve radically in terms of sustainability, in terms of productivity, speed, safety, and a number of other things. I think still that industrialization offers many ways to address that. I say many ways, different recipes, same ingredients, and to succeed, digitalization is crucial. So thanks for letting me give my view on this, and I'm eager to continue the discussion.
Thank you, Jerker. It was great to see that diagram as well, which has captivated my attention for quite some time. Our next speaker is Professor Jennifer Whyte, who is head of the School of Project Management at the University of Sydney and is also director of the John Grill Institute for Project Leadership. Jennifer has substantial experience at leading interdisciplinary research teams to have an impact on practice at all levels. She retains a position at Imperial College London, where she was director of the Centre for Systems Engineering and Innovation, and the Royal Academy of Engineering and Laing O'Rourke Professor of Systems Integration in the Department of Civil and Environmental Engineering from 2015 to 2021. Jennifer, I have to make this quick. Jennifer has worked and studied at many of the most reputable research universities around the world, and there are too many in her CV to mention. Believe me, they are all the reputable universities in the world. And her work has had significant impact on transforming industry and policy. She's a member of the UK Construction Leadership Council and is a member of the Transforming Construction Advisory Board, among very many other esteemed roles. She also curated the World Economic Forum Engineering and Construction Transformation Map from 2016 to 2019, which is one of my personal favourites, Jennifer. I don't think I knew that until I read your bio, so that's wonderful. And finally, she has worked with Singapore's Building and Construction Authority to deliver Singapore's integrated digital delivery strategy. Quite an achievement. I'd like you to join me in welcoming Jennifer to the podium. And if we could cue up Jennifer's slide.
Thank you. Thank you for the kind introduction, Matthew. I'd also put a slide together just to explain who I was, but I want to just pick up on one piece of my experience that I think is relevant to this conversation. So before I joined Construction Leadership Council, I was part of a committee in the UK that was holding the construction industry to account. And it was set up in the aftermath of a disaster that we had. So we had a disaster, a Grenfell tower, a housing tower that went on fire. And I wasn't part of the inquiry for the Grenfell disaster, but I was part of the committee that was put together in government to look at how we held the industry to account to change as a result of that. And one of the big things that Judith Hackett, who led that committee, was really interested in making the industry do was manage information better. And so think about digital information and that golden thread of information through the process of delivering buildings. They were particularly interested in housing that buildings that people sleep in that are more than 6 stories high, which they saw as being safety critical. And so they wanted our sector to look at itself as a safety critical industry and to think really hard about how we manage our processes to deliver. My background has been in research, and so I've been part of similar initiatives around industrialized construction, and particularly around digital technologies and how they're used. And I think when we start to think about digital information and how we use that in our sector, we bring into our view a whole different supply chain of kind of software providers and kind of digital tools and so on that moves at a very different speed to other parts of the supply chain that we interact with. And so I think it brings some challenges as well as some opportunities, and it would be interesting to see what kind of discussion we can have around this connection between digitalization and our sector. I wanted to just think about that process of how we deliver buildings, and design for manufacture is something that we've talked a lot about in the circles that I've been part of. And this is Langer Rook's factory in the UK. And really that idea of designing for manufacturing processes to make it easier to manufacture, to optimize manufacturing, and consider cost-effective materials and processes in the production from the early stages of design. And I think when we start to think about industrialized construction approaches, a lot of decisions need to be made earlier in the process and things are locked in, and it's not quite the same sort of traditional approach to a project delivery. And I'll say a little bit more of that at the end. Design for assembly, so making it easier to assemble on site to optimize part and system assembly. Considering cost-effective numbers of parts, handling, assembly, operations. And this might be considered both off-site and on-site. And the image here is of what was for a moment the highest volumetric housing in the world, and when it's in Croydon, it's a steel-framed volumetric housing development in Croydon by HTA Architects, and when I know they're very, it probably isn't now. So when my colleagues from Singapore were over, they were kind of talking about the volumetric production that's going on there. But I think, it's not just designed for manufacturing, it's designed for assembly on the construction site that I think is important. We've tended to think about it in terms of a systems engineering process. And what's important, I think, about a systems engineering process is that verification and validation is at its heart. So having good information, ensuring that your information is robust, ensuring that what's being built on site connects with the digital information that you have, and that kind of process of ensuring a robust delivery, I think, is very important. This diagram is often thought of at the level of a single project. So thinking about verification and validation through the process of delivering a single project. I think what's interesting when we start to think about industrialized construction is we start to think about innovation at the level of a portfolio of projects. So rather than thinking about innovation in a single project, we can start to think about portfolios of projects. And I wanted to, this is my last slide, so I wanted to kind of end my my little presentation at the beginning by just flagging some work that we've been doing also with Alexander Joe, who's in the audience, on the kinds of digital project capabilities that we've traditionally thought of, and the kinds of digital manufacturing capabilities that in construction we're sort of starting to begin to think about having. And really what I took away from this sort of exercise of mapping the project capabilities and the manufacturing capabilities is that when we start to think about industrialized, digitally enabled, industrialized construction approaches, and particularly digitally enabled product platforms, they're really changing the decoupling point, if you like, where a manufacturing industry meets a project-based industry. And that shift is sometimes difficult to get a handle on, to really understand the sorts of skill sets that we need in construction to be able to deliver safety-critical buildings, sustainable buildings, buildings where we have information about the assets and we can run them sustainably. And so I think there's lots of reasons why digital information is really vitally important to us as a society, and not just as companies, but as a society, to be able to run our built environment better, to be able to understand it better. And that's really kind of where I'm going to end my pitch, and there's lots of things I think we could talk about. Thank you.
Thanks, Jennifer. Our final speaker of the day is Daryl Patterson, who's Professor of Practice at Monash University, and he's also founder and Chief Product Officer at Lendlease Digital. With over 25 years in the Lendlease Group in roles in construction, development and digital technologies, Daryl has led research and product strategy that now supports Lendlease's solutions for property development, building design and off-site construction. In other words, he's uniquely qualified to speak at today's panel. From 2018, Daryl has been also Lendlease's Director of R&D, and prior to that he was Head of Operational Excellence at Lendlease from 2012. Daryl, as some of you may know, was also a huge influence on the founding of this CRC back in 2019, sitting on the 7-person interview panel that we took to Canberra way back in November 2019. Since 2020, Daryl has also been Professor of Practice at Monash University, and like other people in the room today, including yours truly, Daryl is also a recovering architect, having received his Bachelor of Architecture at the University of Auckland in 1994. Daryl.
Thanks, Matthew. Great to be here, and sorry to have to admit 25 years at Lendlease. I think that just means I can't get a job anywhere else. I'm not sure about being uniquely qualified, but let's have a bash at this. Matthew asked that this be controversial between the three speakers and we not talk to each other. I think we're going to disappoint him because we're all largely in heated agreement. This slide is 9 different examples randomly selected or somewhat randomly selected from around the world. And these are all facilities constructed to support this idea of industrialization for the building industry. One of them is Lendlease in the middle. And the story of the slide is a third of it, they're thriving, they're successful businesses. A third of it, they're endangered species, they're on life support, and a third of them are shuttered and gone, which includes the one from Lendlease. And what we can see with these businesses, they're really impressive, right? They had fantastic technology, different range of products, very smart people. They thought their processes through, they did their market research, they had excellent business plans. And they ranged in scale from $10 million of investment to over $200 million in one example. So this bears a little bit of scrutiny as to what's going wrong if we're getting these fantastic investments with these brilliant plants and it's not paying out. I think it's helpful to categorise what's starting to emerge as a series of different delivery paths for our industry to see where these things fit. We know conventional construction, we've had off-site construction for at least 200 years. It has a great place, it serves certain needs. But we've now got these new pathways emerging of manufacturing. And the difference between off-site construction and manufacturing is really an economic one. And what we see with manufacturing, in my definition at least, is that there is a repeatable product and a repeatable process. And I think Yoko was referring to that as well. And why that's important is that repeatability gives rise to a learning effect. It's that simple. We learn how to make something better, it becomes a better product and a cheaper product. And that's that economic impact, which those first two processes don't yield because they're very much about bespoke delivery. Something that's pretty recent is the emergence of site robotics. This is finally becoming real. We're seeing the first couple of examples just land on projects now. And really the key point of this slide is exactly what Jennifer was talking to, that if you want to get to these other delivery paths, there's this crucial thing called design for manufacture and assembly, and it's very different from our traditional design approach. And it's being taught in some places, but not in enough. So what's missing? What are we not doing that is allowing this industry to move forward to these new delivery paths? Well, I think the first thing is we're not seeing a consistent product. We're still overvaluing the bespoke versus this idea of standard SKUs. Something almost all these business plans are getting wrong is this idea of a consistent pipeline. And it's a scary issue because it's whatever you've written in your business plan multiplied by about 10 to get to the level of consistency to drive those factories that we saw in the first slide. But one of the killer issues is we're not delivering on the D in DFMA. We're giving it lip service. We're talking about it in these forums. There's a few educated designers out there, but we are not intentionally designing our buildings so they can be manufactured. And that's a problem because without these things, we just don't get to that economic benefit. So if DFMA is so good and it's doing so much for so many other industries, why are we struggling with it? And I think these 6 points come to mind pretty quickly. There's some DFMA knowledge in the industry, but it's not where it needs to be. It's scattered randomly amongst the suppliers. It's not explicit. They're not hiding it from you. It's just no one's really asked them to make it explicit. So it's not available to the designers who ultimately need it. Research that came from Building 4.0 and preceding research pointed to the fact that we haven't really written the DFMA rules yet for large objects. They're very well known if you want to manufacture a toaster or a washing machine, but does that translate when we're doing something of thousands of tons, large-scale components? And then the issue of sequence, and I'm talking about design sequence. So, you know, I am a recovering architect. I know where we start the design process. We do it in the macro issues. We think about schematic design long before we get to detailed design. And I'm not really interested in contemplating things like floor panelization and connector systems when I'm thinking about concept design and massing. But these are fundamental things if we're going to get into this DFMA space. Responsibility. I think there's a few design professionals that say, I'm not sure why this is a problem that I need to get involved with. This sounds like the builder's problem. Surely they're going to be the ones who are going to solve the delivery process. And I think we've got to look at it differently and say, it's not the builder's problem, it's not the architect's problem, it's all of our problems that we're going to have to come together and think about. A real pain point is analysis. We really haven't got the analytics available to us in easy, accessible ways to understand the key questions. Is this kit of parts approach here or this DFMA solution there a smarter, cheaper, more effective solution? Is it high risk? Is there a better way to arrange it? Those tools are not readily available to the industry to make those decisions. So we start making them on the wrong basis. Fear, negativity, risk. And something I've heard very little conversation about from anyone in all the time we've been talking about this is that if you want to get into manufactured products, there's exponentially more design information required to be able to do that. And we learnt that the hard way through the factory we set up. And what I'm talking about is in this example here. I mean, this is pretty much the simplest construction method I can think of. Light timber framing, it's used in a lot of places. A skilled carpenter doesn't need much information. The basic plan on the side of the image there and hopefully an elevation or two, and most of the time they can do a pretty good job, right? It's a low level of information. Now you can buy machinery and set up factories that can make these wall systems. They're all around the world. That machinery requires a lot more detail. It needs to know the cut length of every single piece of timber. It needs to know the position of every single piece of timber, and it needs to know where every nail is going to go to hold it all together. I don't think that's something the design professions are particularly interested in spending their time creating, which is a good segue into the digital opportunity. And so we can use software today to start to generate high design detail. And that's something that Lendlease Digital has been particularly focused on for the last couple of years. We can also build those analytical tools and we can put them alongside that design generation. And if we go back to where is that DFMA knowledge that the suppliers are holding, well, we don't want that published on websites or put into catalogues or, maybe relayed in a summit. We want that to be encoded into the software so that it's always available as part of the design process, that we make the right decisions as we do the design work. And then the fourth dot point we've heard about a couple of times today, and this is this idea of file to factory, that we should be able to manufacture direct from the model. And we've seen some examples of that, and BIM's got us a little bit down the track on it, but the real issue there is back to that design content piece, that if there's not enough detail in the BIM model, you're not going to manufacture from it. And that's got to be a solved problem if we're going to take this forward. And then the last dot point is perhaps the most boring one, but it's probably the most important one in my slide deck, that we need to get to a common language, a way of describing all of the building fabric, a way of describing all of the design tasks in a way that enables an automated integration of the parts. Designers are great at design. They're less great at integration. When we see the problems that show up in building designs and the failure points and the disasters that we've heard about, it's usually where one material joins another material. The integration is always a challenge. If we think about common languages, the technology industry, it was also poor at this historically. It's become very good at it. If you think about things like Bluetooth as a standard, it's the same standard whether you're in Nigeria or Norway or New Zealand. And how did that come to be? It certainly wasn't because the governments of those countries got together and had a forum. They'd still be picking the venue. It was really pushed out by the tech industry. It's kind of a forcing mechanism that if you want to play, you've got to conform with a standard. And I think that's one of the things we're going to see emerge with the shift to a platform-based technology approach. So, a digital construction platform. Here's one abstract view of what that could look like. The single job of a platform is to connect party A to party B. In this case, it's the suppliers to the industry and it's the designers who want to consume the products that they have. We could think about that in two different ways. We could think about proprietary products that a supplier makes that no one else has that could be offered up as a standard component and listed on in a catalogue on a construction platform. And we can go the other way and say, why not specify some generic products? Maybe it's the idea of a curtain wall or a wall system or a bathroom pod. And it has attributes that are defined clear enough that multiple suppliers could offer up their alternate for that product. And if we've got that sitting there, all that content with those SKUs, we need to add a few things to it. We need to write those interface rules. We need to talk about how Part A will fit Part B, how System 1 will talk to System 2, so a system of space informing a system of structure. And then we can make those systems generative. We've seen that happening all around the world in design practices already, that we can take algorithms and we can get them to do multiple design tasks. But then the fun stuff happens, because if you've got the output of that, you can take all of it and look at it in a combinatorial fashion, and you can make an assessment. Is it good? Is it sustainable? Is it safe? Is it economical? And then the best thing is it's recursive. You can take that information, you can feed it back through the generative system, and you can let those systems start to optimize based on that assessment. Think of it like goal-seek in Excel. You can start to take all the parameters of a project and hunt for better and better outcomes. So if I've lost you, or it sounds like a little bit of fantasy versus fact, I'll give you a couple of minutes here of some snippets of what we've been building. And this is very much a digital platform that does automate parts of the design. I'd like to offer up perhaps there's a fifth level to Jyrke's diagram, which is a generate to order model. And so what we're looking at here is a building that's not drawn, it's not assembled from a BIM library, it's fully generative. And it solves not just the geometry, but the actual physics. So it's starting with the task at hand to say, what are the loads the building must carry? What are the forces that will be present at each connection? And what it does then is it goes off and it looks at those catalogues, at those standard SKUs, and it says which components will satisfy the tasks that the system is calling for. And you can see here it's called up connectors and hardware to install them with, and it's placed them correctly into the timber, and it's detailed the timber. It's that level of detail that none of us are interested in actually drawing, but the machines that are going to produce this are going to need. And if you speak BIM, it's an LOD 400 model. So with all of that information being generated automatically, we've got a rich series of possibilities of what we can do with it. We can obviously produce bills of materials like this. We can have them priced at a very detailed level. We can use this information to order and plan the project with. We can cut and dice it and give it to the sub-trades in a way they never had clarity on before. We can do some other things. We still need shop drawings. The machines don't need them, but the supervisors who look after the machines do. No one wants to draw shop drawings. It's very tedious. No one came out of university saying, let me draw shop drawings. So let's automate that process. Click on anything in the object model, and it will produce a standard 2D drawing. It'll annotate it, it'll add the dimensions, and it's ready to go. Now we can start into some real DFMA concepts. We can say, well, let's examine this building for its efficiency. This is intended to be a mass timber building. The CLT panels are cut from master panels. The level of waste that's left behind in the factory has to be paid for. So if we want to make this building economic, we need to minimise the waste. The yellow on those panels there is the waste piece that's not being used. As I said, it's a recursive process. You can run this design loop as many times as you like to minimise that waste function. Second stage in this DFMA process is to look at logistics. We've got to truck this thing from a factory to a site. So an extremely tedious process to have humans do, but digitally straightforward. Let the software plan the loads. Let it figure out the weight and balance of every truck movement. Let it figure out the construction sequence. And now that we have this information, we can understand cost and we can understand the carbon footprint that's associated with these traffic movements. And it always comes as some sort of a shock to people that that little 7-storey timber building there needs 91 truckloads of movements to get to the site with the timber frame. And then the third, before we go, that information, of course, can be shared with different parties in different ways. We can give it to the manufacturers, we can give it to the trucking companies, we can give it to the construction teams who can inspect the trucks as they're arriving to make sure that it conforms with their expectation. And those sorts of information reports look like this. So, as I said, very tedious work to have humans do. And the real point here is this is happening 2 to 3 minutes after the first concept moves are made in the design. It's not something that happens a year and a half later when this has been handed down the chain to the suppliers. Third and final stage of what we're showing here is the schedule automation. So instead of asking a construction person to plan out the job, the software is planning the build sequence. It's showing us a model for each week of the build. So it's a nice clear visualization of what's going to happen. And again, we can run multiple scenarios. So we've laid out a base scenario there, and we can ask a question. What if we use a more expensive connector type between some of the components? It's more expensive, but the manufacturer says that it will require less labour and it'll take less time to put the building together. And that's the answer we get here. And we can keep running these scenarios. We can add resources, we can add cranes, we could change the number of crews working, and we can model the economics of this, and we can tell the client, you want to build this building cost effectively, here's the best scenario. And at this point, we haven't involved a builder, we haven't gone out to tender, and we're still playing at the concept level to understand what the possible options are. So in conclusion, I very much have to agree with what we've heard from the previous two speakers, that this is not an or question. It's not a question of industrialise or digitise and jump to one or the other. It really is an and issue, that you need both, in my view, if we're going to move forward. So thanks very much. I'll close there and look forward to some questions.
Hello. To the control room, can we get Jaakko back on the screen so we can see his face, please? Jaakko, did you get all those presentations, Jaakko?
Yes, I did.
Wonderful.
I did, and I enjoyed it every minute.
Wonderful.
Thanks a lot.
I can see we're in a group here of the true believers. You've entered into a secret sect. Wonderful. Look, I hardly know where to begin, because there's so much in each of those presentations that it is sort of almost daunting to make a start on this, because it makes every question somewhat trivial. So I'm going to give everyone in the audience a heads up that this is going to be one of those interactive sessions, so get your questions ready. Daryl, I might just start with you, because your opening slide suggested industrialization has been, if I understood that, the purpose of that slide pretty well, it's that the industrialization approaches that you've made have been hit and miss, right? And if we start from your first slide and end up at your last slide, I'm seeing pretty much a progression from starting with what I would see as industrialization projects, notwithstanding what Jaakko said, saying that industrialization in his definition framework incorporates those digitalization tools. But by the end, we are very, very focused on the digital. So I guess the question I'm trying to ask here is to come back to the hit and miss part. Was that a necessary step for you to get to the end? Do you think you could have painlessly got to the end, or do you think that was part of the hit and missness of it?
I think you're referring to the experience that Lendlease had with a couple of different plays in manufacturing. Could we have jumped past that straight to a digital approach like we are doing now? We had to go through a learning curve, and I think what we see with the various investments around the world, people repeat the same learning curve. You want to bang your head against the wall watching them do it, and I'm sure you've seen a lot of them as well. People think the answer is a really sophisticated factory, right? A bigger factory, more robots, the more technology that goes in, it's going to be great. It's going to really, change the universe of construction. But I'll say it again, if you are trying to do that without a product, then you're not in manufacture. You're in some sort of service offering where you do bespoke work. And you might do it really well, and you might make great things, but I don't think you'll economically transform the solution. And isn't that the goal, right? Aren't we trying to find a better way forward that uses less materials, has less impact on the planet? So if we're not getting that kind of delta out of this process, I'm not sure why we're embarking on it. We're just making the manufacturers of the robots wealthier. We haven't actually solved a problem. And for us, what we realized is, well, we have to go look at this product issue. right? And that's a head scratcher because our industry, firstly, it really values bespoke solutions. All architects in the room, recovering or otherwise, you know, you get more excited about bespoke than someone saying, I want to repeat the design you did last time. And then there's a reality, right? Building sites are all different. Legislation is different. We know this. We can't make the same building everywhere, so we have to have this range of capability. So for me, you know, our team did its best work in thinking about how to solve that problem, and it was really in the generative space, using these components in a way that they could be configured really intelligently. And we still haven't got all the answers to that. There's a lot of gaps in how some of that will work. But you close the gaps by putting the analytics on top to try and figure out what is potentially working and what isn't. So I think, you know, long answer to your question, but you had to go through the journey to get back to the starting point to say, what is the product, right? And then finally, if you can get the product right, you might be able to solve that pipeline issue that, you know, pipeline depends on 100,000 bathroom pods of the same type being used by the industry, not 50 or 200 or 300. And so a system, a platform that encourages the adoption of, you know, components at that level of uptake is what will really transform the industry in my view.
Thanks, Daryl. Jaka, multiple recipes, the same ingredients. Looking at Daryl outline within 10 minutes the sort of comprehensive efforts of he and his team and the company have taken over the last 10 years. Do you see all the same ingredients there? And to take Daryl's lead, is the recipe that he's just outlined for us now on your chart of recipes? Is that called a product recipe? What do you think about that?
Yeah, I mean, if we go back to the model I showed with 4 different levels of platform predefinition, I think this definitely plays well into that. I would place your approach on a level 3 there, fairly advanced, fairly high level of predefinition of the included components and the processes and the ways to work, but there's still a pretty wide opening in what end products, what kind of buildings you can produce on that. So I think this definitely plays well into that, and I think that that kind of strategy, I think, has a huge opportunity, huge place on the market. I think the lowest level, where it's really standardized, almost end products, but with some configuration opportunities, of course. I think the market for that is actually smaller, but it can be super powerful for the right customer segment or part of the market and so on. But I think the level 2 and 3 have the biggest market opportunities, especially if we see that's where we can take big competition, so to say, with the traditional construction, because we will still build very varied buildings, but with a higher level of standardized content. And I think, but maybe that's a question to the audience, and especially architects and maybe real estate owners or buyers, clients. What's most important? Is it important to have bespoke buildings? And is it also very important to have super unique solutions behind the wall, and how the wall connects to the roof or to the ceiling and so on? Is that important, or is it more important to focus on creating great buildings, but let us use some standardized and smart and really reliable components? I also want to pick up, but we can have that maybe as a second round. I really liked what you talked about, the level of design. When we go into this space, there is not only an opportunity but a requirement to get really deep in design. I think that's not only difficult and it's not only a challenge, it has such an interesting opportunity in terms of design quality. But let's come back to that, because I think that's something to discuss further.
Exactly, Jaka. Let's come back to that, but let's also not skip over the fact that if I heard you correctly, you just squashed Daryl's attempt to try to get a 5th category in your model.
No, I mean,
I'm looking for any disagreement I can get here at this point in the.
Let's have that as let's join forces and see if we can put some continuous improvements to the model. Why not?
Is that 4.5, Jaka? 4.5.
Exactly, for 4.7, Michael.
Thank you, Jaka. We will indeed come back to that level of design, because I do think that is a really important thing. But I want to go to Jennifer, and I also want to pick up on a point that was raised in Daryl's presentation around DFMA as well. Listening to both of your presentations and the centrality, if you like, of DFMA and the ubiquity of DFMA in discourses around industrialization and in our day-to-day work, I kind of wonder whether it's the hinge or the glue between industrialization and digitalization. I was interested in Daryl's presentation to see how he's going to take the turn to go from DFMA to digital. He's outlined one method. Clearly, your invocation of systems engineering, I think, is really critical, and I'll have a follow-up on that. But I just want to get your take on the positioning of DFMA. It is a concept that kind of floats around in all of this discourse. How do you place it?
Yeah, I mean, I've been in lots of discussions about DFMA and design for then the through life of the building. So not just its manufacturing and assembly, but how do you think about that, those assets through life? I think what's really exciting about some of the tools that we're seeing, and we're seeing them in Daryl's presentation, and we saw some this morning. I can think of examples from the UK that people like Bryden Wood are engaged in, where organisations are beginning to employ different kind of personnel, people who have data science kind of backgrounds and are able to work with people who understand construction to build new kinds of tools, these kind of multi-criteria design tools that allow designers to see a whole range of different information about buildings. And I think that's really powerful. I mean, for me, it's about the digital information, and what that information is telling you about the real world. And I think what's nice about them is that they're also extendable. You can imagine if you want to think about, kind of sustainability in terms of projects as interventions, you can start to add information about the surrounding area, you can start to add information about, animals and ecosystem and, all the things that we were talking about in Berlin. So, you know that once you start to think about design in this sort of multi-criteria way, there's all sorts of opportunities. And, in Imperial, they're doing some work at the moment looking at housing and water. And how do you think in a planning perspective? But they're using similar sets of techniques that as those that we're talking about here around design for manufacture and assembly. And I think that's a really powerful area for digitalization in our sector.
Yeah, that provides a very interesting step through to the next point that I was keen to pick up on, which was around. Daryl briefly mentioned it, encoding knowledge. And I think it's implicit in your, as I said before, invocation of systems engineering, right? It kind of implies a few things, I would suggest, Daryl. Firstly, we have to have the knowledge, which is maybe a shout out to the research side of the room assembled here today. And then we have to encode it. And as Jennifer's pointed out, that's requiring a whole different set of analytical thought processes. I'll ask you both what you think about this encoding knowledge problem, starting with you, Jennifer.
I mean, yes, of course, it's a challenge. And when I've been teaching in this area, there was a kind of transition point when I used to show a simulation It was actually of a. It doesn't matter what it was, but it was actually of a lorry driving into a building. Yeah, and there was a simulation of it, and there was actually a real-world kind of analog. And it was quite interesting because there was a tipping point when, you know, for some years students were really interested in the digital, and then after a while, everyone just assumed the digital, and they were kind of interested in the real world. You know, and I think for me it's that connection between people who are digitally savvy and people who, connecting that. You know, and I think that's been one of the challenges for our industry under COVID, right, is connecting people who are working digitally on their computers at home with the real world of spaces and places and construction and so on. And so I think it's that connection is the challenge for us.
Daryl.
Yeah, I think initially collecting the knowledge does look to be a challenge, and you do need some different skills around it. I think, you know, not being from a software background, but now working with a team of software people, the criticality, as I said, of a common language, but also of a data schema that can hold the attributes which would describe that knowledge. Right? We don't think in those terms when we think about design. I think systems engineering is a critical, you know, process to start thinking that way. But I think beyond that, there's a lot of things that you can't go and ask a supplier and get an answer. You can't ask a designer and get an answer because they're operating from heuristics, right? They would really, you know, look puzzled if you ask them to explain why they've just done what they've done. Now, how do we tap into that, right? Well, the best way to do that is to build early versions of software and get people using it. And then, you know, scary as it may seem, observe what they're doing with the software, learn from it. That's a great application of AI. Right? Understand why a designer makes a certain move again and again and again. Now, take the heuristic, turn it to knowledge. It's the same with the manufacturing steps, right? And some of it, once it's unlocked, becomes abundantly, obvious to us, but some of it takes a fair bit of time to mine into. And we've certainly followed some dead ends here. I showed the framing example of light timber frame walls. We had someone do a piece of work who said, oh, there's a possible 99,000 different ways to, you know, configure the timber in a timber frame wall. Well, mathematically there might be, but the carpenter has got about 16, right? And they can make just about every wall shape from 16. They don't need that, you know, full range of possibilities. So your question is, how do you unlock the 16 ways as quickly as possible, capture them in the software? And I do think longer term it will be observing what people just do and capturing the heuristic in a way through the software.
I want to push that question to you as well, and around the question around encoding knowledge. And a particular image springs to mind here. I think it was a visit to your Gulringen factory, if I'm not mistaken, back in 2016, and I was taken there by Duncan, who's sitting here in the audience and says hello to you. And not to me. I remember going everywhere and seeing these sort of alphanumeric codes that were printed out sort of every day at every station, explaining, I guess, to the system how, you know, where everything needed to be at a particular point in time and how many things were going to that station per day. But I guess that image just jumps into mind right now, thinking about this issue of encoding knowledge. And how you actually put some of these high-level strategic ideas, such as the ones that you've got in your framework, into action in your day-to-day work at Boklok.
Well, first, I think Boklok's recipe for industrialization has been a step-by-step approach. So we did not start in 1996 by investing billions in building the most advanced factory in the world. We actually did not even buy a factory. We started off by relying on external suppliers. Then after a couple of years, when we felt, or I wasn't with the company then, felt that it works, okay, it's time to really take the next level of control, meaning where they acquired the factory, very simple factory, almost no automation, but standardized processes, standardized products, working with that repeatedly, learning. And of course, back then, a lot of the knowledge was in the people. And then the recipe continued, taking small steps all the time to increase. And now, 3 years ago, we took a decision to take a leap forward, to invest some money, 250 Swedish million, so around 30 million US dollars, so if we translate it, in our factory, to really increase the level of automation, really take a leap forward in digitalization, because hard to automate without digital data, and I mean to feed the machinery and so on. And also a system to really track what is happening in the factory. When do we stop? Why do we stop? How much material do we use for different stations, and so on and so on. So it's been a very long journey for us. I think starting a company similar now wouldn't have to have 25 years to do that, because there are many more to learn from. But for us, that has been extremely important, to take this step by step and be sure of what we do. And I mean, to really know that we had the market, we had the customers, we had the pipeline, as you talked about also, Daryl. Since we are project developers, we actually secure the pipeline ourselves. But to do that and feel that we are doing the right things and then take the next step, that would have been extremely hard if we were doing too wide of a variety of projects, making too many sort of unique solutions. So that has been very beneficial for us. And now we are we have two super clear focuses. It's sustainability. That's extremely important for us. And one way to really make that happen is to be more digital. And what is digital then? Well, it's both using digital tools and to make things as we have talked about, but it's also data. Since we repeat our processes, our products, and so on, well, the data about what we do is the gold. So if we can really turn that into the part where, in my framework, where when I talk about systematic measurements, well, what do we need to do that? Well, it's data. And what feeds continuous improvements? Well, that's data. So when we can do that on a higher level, then we will be even more successful. So super important.
Thank you, Joko. I'm going to ask for some questions from the audience. Questions, please. Yes, Bronwyn.
Thank you. And I'm not sure who will be best placed to answer the question, but I'm really curious if DFMA approaches are only applicable for future buildings, or could it be used for retrofitting projects, like when we need to, say, update the cladding in a broad range of really odd-shaped buildings, say in Victoria or in the UK as a result of the Grenfell fire? I'm just wondering, is that an application?
I mean, I think it is. I don't have any great examples of where it's been used in that way. I mean, I think the comment that I would make was, if you look at the crossrail cladding, Lang O'Rourke worked with Australian R&D to wax mould the molds that they used to create some of that. And I think that kind of hints at a more flexible approach, which you start to need when you start to talk about interacting with existing buildings.
I don't see why not. I think, manufacturing, we're looking for volume. Maybe retrofits don't always offer the volume. Maybe they do. right? Maybe particularly in those cladding examples, we could be looking at more kit of parts approaches, and actually maybe DFMA is even more critical because, you know, having had to rectify defects in occupied buildings or trying to get them reoccupied quickly, that's incredibly painful. So why not streamline the assembly process, right? Seems to make sense.
Thanks for the chance to ask a question. It won't feel like a question, I suspect. And some of you know, I thought about this stuff for a while, but Germa's example of Boklok's what got me to finally put my hand up here to say something. Because for me, it's that kind of patience in understanding how to learn to get to the point to satisfactorily make a $250 million investment for the next improvement that we've lacked as an industry. I define industrialisation as implementing systemically repeatable ways of working. That's it. And then on top of that, you can build systemically repeatable ways of improving, and that's, Daryl, what you talked about in learning effect. And for me, our episodic application of lessons learned in manufacturing over 100 years of evolving through total quality management, the way they work, and dropping them into a value chain of work that is not yet systemically repeatable is why we see 2/3 of those factories either dead or in trouble, because you're landing new ideas into methods of work that are still random, so they die. So I think as an industry, we still take this mud at the wall approach to improvement and get surprised when things don't succeed. So let me call that a comment bearing, inviting your perspective.
Thanks, Bob.
I just a comment on that. Oh, sorry, Jennifer. A quick comment on that, I think, is what we maybe a little academically refer to change of business models. What I mean, the essence of that is actually try to move away from being single focused on one project at the time, creating unique solutions. Try to take a couple of steps back, see, as you said, Jennifer, a portfolio of projects at least, or like in Boklok's case, a very, very narrow range of well-defined, we call it products, meaning our homes and buildings that we build. And that's a completely different way of sort of attacking the problem. If we see it as products, or at least platforms, then there is a different way to deal with it than we are used to in the scope of only projects. That's just a quick comment, sorry.
I have a quick comment on that as well, because I think at an industry level, trying to drive out that variability, I always think about the opportunity for the research base here, right? Because if you look at the International Motor Vehicle Program, which invented the term lean, that was a international collaboration of researchers looking at and comparing production of motor vehicles in the US and in Japan, and really asking the question as to why the Japanese motor vehicle producers were able to deliver much more quality, high quality, faster, cheaper, on all the metrics. And, I think that there's a real opportunity to kind of document some of this, to be able to make people go, aha, I really understand it now. Yeah, and I think that's an opportunity really for the CRC here.
Look, going back to Jyrka's comment about business models, I think, Bob, you're right. If you throw mud at the wall and you go build a factory and hope someone comes along and gives you an order for the factory, that when you look back at it, it's a bit random. I think a platform that a number of people are talking about here today, you started with platforms, Mathew, at the beginning of the day, that implies a different business model. And that's probably the next big risk or fail point that could, will the industry move to these radically different business models? And we're yet to figure that out because there haven't been a lot of customers for them so far. So I think, to your point, there has to be demonstrable value, right? This has to be faster and better and, lower risk and doing lots of smart stuff that we're struggling to do at the moment. But I'm pretty optimistic. I think we can see the potential of them to deliver those kind of dividends. And there'll be early adopters and there'll be laggards, and we'll see who's who. You know, and I just want to finish by thanking Jennifer for paving the way with the BCA in Singapore, because they really understand this, and we've now got them as a client, so thanks for that.
I've got two questions. The first question is whether you guys planned your outfits before the panel. My good, I'm glad. And my second question was around, directed at Yoko, but also to the whole panel. You talk about the 4 different platform approaches, and they offer different scales of standardization. And Boklok has seen incredible success in Sweden, and you guys have also dabbled in the UK. And we were talking about markets earlier, and I'm just wondering whether you could reflect on whether there are different market expectations in the UK than, for example, in Sweden, and whether that has enabled a certain degree of standardization to facilitate the success of your company in those different markets.
It's hard to know if there's a difference in expectations in that sense. I think what we have really a focus on for Boklok as a whole, it's the customer appreciation. So we really make an effort to understand. So before we do anything, when we entered the UK, we really tried to understand, okay, so what are the needs here? They are, of course, to some extent similar to what we know from Sweden, but they're not exactly the same. So what are the demographics? What are the financial situations for the different customer segments? I mean, really trying to dig deep, much deeper, of course, much deeper than doing before one project, because we are going in this for the long run, so we want to make it as right as possible. So really trying to understand what's important for our customers, what they can pay, where do they want to live, how do they want to live, how big are the families, and so on and so on and so on. And then try to take that knowledge as input to our product development. And the houses and the homes, the apartments that we are building in the UK are not the same as we are doing in Sweden, of course. But we are doing it in a very similar way. We are producing in factories. We are producing in volumetric elements. We are assembling them on site and complementing on site, and so on and so on. But also we are dealing with sales in a very similar way. By the way, in collaboration with IKEA, so we have sales events at IKEA stores. But we also take care of the whole sort of customer journey in a very similar way, and so on. So, and in our initial phase, we of course understood some of the expectations. We could see some differences from Sweden and Norway, Finland, that we were more mature on, and we could sort of tweak the ways, both the products and also the ways we are working, but following the sort of the Boklok recipe to a very high degree. But I think it's super important to state that we're not building identical homes in our different markets. That's the easy part almost to change. In traditional construction, that we change in every project. That's obviously fairly easy to change. But the tricky part is, of course, to stick to a concept, when you have chosen your track, your path, your narrow range of products, stick to it. Don't buy that piece of land where your products don't fit, because then you will end up in trouble, not making money, and the customers will not be happy. So just to end this, we are super proud, because in Sweden we have done these customer surveys. We participate in the national customer appreciation surveys every year, and we've done that for many years, done by a institute. And we, year after year, we are in the absolute top of customer appreciation, which is interesting because we had almost the most standardized customer offering in terms of our apartments, but we have the most satisfied customers. And that's interesting, I think. But I think it has something to do with predictability.
Thank you, Jerker. My voice was louder than I anticipated it being just there. Felt a little religious to me at this hour of the day. Sorry about that, everyone. I seem to have drifted off. Stick to your path, Jerker. I like that. I think that's a really nice point to end on, and something that all of the people who've been involved in industrialised building in this room, of which there are very many, have grappled with in the night, in the dark, and into the early morning hours. And I think it's a really interesting point that you raise. I think it's been a fantastic session. As you can tell, I think if we had more time, there'd be many more questions from the audience. But we are eating viciously into our drinking time down here, Jerker, and I'm sorry you won't be able to join us. There are approximately 5 minutes standing between drinks and this audience that you can't see, that consists of around 200 people, Jerker. So I want to thank Jerker Lessing, Jennifer Whyte and Daryl Patterson for what's been a fantastic session closing the conference today.